So we installed some packages. Then we were having initially our host operating system. After host, we started making our own operating system by having a pass1. Then we had a second iteration of the same packages, that is pass2. And then now we are having, in this video, we'll be making a pass3. So inside packages, what all packages we installed? We installed Binutils. This is our tool chain. Binutils GCC and Glibc. These three packages provide us the tool chain it provides. So this was our first iteration that we prepared our host operating system. So this Binutils provided AS and LD. Basically Binutils provides so many binaries, but mostly we are interested in AS and LD. The GCC provides us many binaries. We are interested only in GCC. Glibc provides us hundreds of libraries, but we are interested in libc.so.6. So that was our first iteration. So we prepared our host operating system. So these three packages has to be installed first on host operating system. Then only we can proceed with building our own operating system. So that was our first iteration. In second iteration, what we had done, we prepared our pass1. Under pass1, we installed a package called as Binutils. We installed a package called as Binutils. That was our second iteration. Clear? So inside this Binutils, Binutils has provided us, now pass1 onwards to pass3, that's our operating system. So Binutils provided us AS and LD. That was our second iteration. Then we went for our third iteration. Under third iteration, we installed GCC. GCC provided us GCC binary. Then we went ahead with our fourth iteration, and that was Glibc. We installed Glibc. Under Glibc installation, we got libc.so.6. That was our pass1. This is our pass1. And we installed all of this inside /tools. So we prepared a host, and by using host AS, LD, GCC, libc.so.6, we prepared our pass1. Under pass2, we again installed the same packages, which is Binutils again. Then we installed GCC. So Binutils we installed and we prepared our own AS, LD. Then we installed GCC. So these two iterations. So that was our fifth, and GCC was our sixth iteration. But we did not install Glibc because when we compiled Binutils, we used a host operating systems Binutils GCC and Glibc. The tool chain basically we use of a host operating system. So AS and LD was affected directly by the host operating system. Same story with the GCC. GCC time also we use a tool chain of host operating system. So obviously GCC binary was affected by the host operating system, but that wasn't the case with the Glibc. When we tried to install a Glibc, we used our tool chain, which is here. We did not use the host operating system binaries. Instead, we used the binaries from tools, and we prepared libc.so.6. So obviously the libc.so.6, that means the Glibc was not infected by the host operating system, and we again reinstalled this inside tools. Remember, inside tools we already have libc.so.6 present there. So now our entire tool chain, so let me write here a libc.so.6 as well. So if you look at here, now our tool chain is completely pure, ready, and now by using this we can go for the Part-3. Now in this video we'll be making the Part-3. So why exactly Part-3? Why we need it? Host operating systems ASLD GCC libc.so.6 were inside /usr. This all was inside /usr. Obviously it has to be inside /usr. Why? Because as per the Psmisc standard, this has to be installed, binaries has to be inside /usr. But in our case, all of these binaries are inside tools. That is not the right location. The right location is usr. So that is the reason what we will be doing. We will be recompiling same Binutils, then our GCC and Glibc. That will be our 6th, 7th iteration, 8th iteration and 9th iteration. We will be installing. So Binutils we will recompile with the same tool chain. So it will provide us AS and LD. GCC will provide us GCC. Glibc will provide us the libc.so.6. And we will be installing this inside USR. So our prefix will change. So whenever we will be firing a command configure, our prefix will be /usr. So up to Part-2 our prefix was /tools, but for this, when we will be recompiling all of our Binutils GCC and Glibc, when we will be recompiling it, the prefix will be /usr. That means what, after Part-3 our operating system will be ready. When this operating system you will give it to your friend, that time he will not be able to use a Glibc, GCC and all, because that is inside /tools, whereas the standard location is /usr. So the end user, the way host operating system has provided us to the end user, it provided us the tool chain. The same way we need to provide a tool chain to our end user. So basically this is where our LFS gets prepared in Part-3. So by using LFS, if someone else want to make their own operating system out of it, for example LFS again, then this tool chain should be ready. The way we got the tool chain from host, same way our LFS will be a host to whoever will be creating. For him, that will be a host operating system. That means our LFS will be as per the Psmisc standard and it will be ready to use. So let's start. So first I need to log into my VM, which is CentOS 6. So here we logged into our system. Now the first thing obviously we need to do, we need to make sure whether all the mount points we have mounted with the correct file systems. The first one will be obviously /dev sda1 on mnt LFS. That's it. Now only this won't work. What we need to do next, we need to chroot, and before doing this, before chrooting, we have to install or we have to mount our virtual file system. So let's do that one by one. So let's just simply copy it from our LFS book. So we mounted the dev file system. Then it's time to mount the dev PTS. Then mount the proc. After proc, it's time to mount the sys. After sys, let's mount the run. After run, it's time for a chroot. So let me copy the chroot command. We already discussed about chroot and everything. As you can see, the chroot is successful. Now we need to start our Part-3. We'll be starting with the API. First of all, we need to go to the sources. Inside sources, obviously, we need to extract the Linux kernel because API is provided by the Linux kernel. So let's extract the Linux kernel package, which will take some time. We'll go inside Linux package, then we'll do a make mr proper. We talked about it. Then we'll simply copy the header files from the extracted Linux package to the /usr include. Last time we installed it inside or copied it inside tools include. Now we'll copy it inside /usr include, right? That's the pass3. So it has been extracted. Let's go inside Linux 4.2. Let me fire the command which is nkmr proper. It will take some time, and then we will fire a make command. This has been done. Let me fire the make. The files has been copied into the destination folder. Now from dest directory we will copy it into the /usr include. Now you can see once this is done, let's copy it inside /usr include. There we have copied ls /usr include. This is the default location of having all of our header files. For example, ASM. You'll find all the header files related to the assembler. Clear? So this was the installation of our API. So let me delete the extracted Linux package. Next, we will be installing man pages. Basically, a man binary we will be installing. So tar-exec man pages. We extracted. Let's go inside man pages directory, extracted directory, and simply fire a command called as make install. We are not installing a binary, make binary. We are installing the man pages. So obviously, compilation is not necessary because these are all text files. Simply copy and paste. So make install has done that. Let's come out of this directory and remove the extracted man pages directory. Now here comes our GCC. So tar-xf glibc. We are extracting it. Next we'll go inside that extracted directory and we will patch it. Same steps what we followed earlier in our earlier videos in pass1 and pass2. Same steps we'll be following. The only difference is the prefix will be /usr instead of tools. So let me go inside glibc extracted directory and here we will patch it. So we patched it. So there is another patch also. One more patch. Let me patch that too. Now we have patched it. Let's make a glibc build temporary directory. We have made it. Let's go inside that glibc build directory and let's hit the configure. So this is very easy. If you understood the concept, this is nothing. So let the configure get complete. And let me show you this is our configure. As you can see, we went inside glibc 2.2.2 directory, extracted package, configure, prefix is usr. That's it. That's the only change. Rest of the stuff is same. Clear? So configure is done. Obviously next will be make. Make will take some time. So as you can see, the make is complete. Now we just need to create one ld.so.conf configuration file that we need to create and start the make install. Once we finish with our make install, we have to do some changes. That is for the NSAD, that is name caching server. For that we have to do some configurational changes that we will be doing. Now, the commands which I will be firing next are self-explanatory, so I won't explain. Done. Now as I said, some changes for the NSCD, that is name caching server or name caching daemon. So let me quickly do it. All commands are very easy, not a rocket science. Those all are the self-explanatory commands, like install. Instead of mkdir or touch, we are using install command. Next is these are for the localization purpose. Next is your language setting, and finally one more time the make command for the local data. It will take 2-3 minutes. Okay, next let's create the NSS switch configuration file. That's what we have created. Going next. Now interesting. Now what we need to do, we have to extract one package. We are still managing our glibc. Okay, so we need to extract one package which will be interesting package, that is TZ data, that is time zone data. You know, to set your time zone. For that we need to compile the time zone data package. Okay, so let's do it. Before that, let's set this variable, which is zone info is equal to USR share zone info. Next, create some directories. So let me create those directories. Once that is done, we need to run this simple script. Now this script is specific to this package, TZ data package. Okay, it's very self-explanatory, not a rocket science. Next is copy the .tab file to the correct location, which is USR share zone info directory. Once that is done, as of now I am setting my time zone as America, New York, but I will change it to my time zone. And how will I change my time zone? The command is tz select. The command is tz select. So here, as you can see, I need to choose. I am from India, so I need to choose first the continent, that is Asia, number 5. Going next, you can find out the India page number 14. Now it's asking me is the information is all correct or what. I'm saying yes, all is correct. Oh, I need to put on a number, which is 1, and Asia Kolkata has been set. Clear? And just last thing we need to about the TZ data is create this symlink. Clear? And we are done with the TZ select data. Couple of other files we need to create, that is ld.so.conf that I have just created. Add some more entries into it. Let me add this new entry into the same ld.so.conf directory. Now let's create this ld.soconf.d directory, and we are done with our glibc build. So let's delete this extracted package as well. Let me delete it. Now what we need to do, we need to adjust our tool chain. So some basic cp and all commands we need to fire. So let me start with this command, which is mv. So what we are doing, we are moving our tools bin ld to tools bin ld old. So earlier ld, which we compiled in our pass2, we are renaming it as a ld-old. Clear? Going next, we are moving the ld to this location, and we are renaming it basically to the ld-old. And the ld new to the ld. So basically we were having one ld ready, we renamed it to ld old. Then the new ld which we compiled, we renamed it from ld new to the ld. That's what we have done. Now we need to create one simple symlink. Let me create that. And the one GCC script I need to run, that we ran. This is it. Now let me go further, and we are done with our toolchain adjustment. All good. Now here we finally reached to our package installations now. Now the first package which we need to install is zlib. Now this zlib will help us in zipping packages, like for example our tar, then our bzip2 and all. There it will help. This zlib will help. Okay, let me go inside the zlib and configure. As you can see, it will be simply, prefix will be usr. That's it. And then make and then make install. That's it. Now I need to come out of this rf zlib extracted package. Let me clear that. So that was the next package, which is zlib, and we need to create, or basically we need to move some files of zlib to the correct directory, and let us create one symlink. So as soon as you start preparing your LFS by your own, you will understand all of this part, these commands. Okay. Next package is the file package. If you remember, we already installed file, but that was in the tools. Now we are reinstalling it inside /usr. So let me go inside file package and configure prefix is equal to usr. We're done with the configure. Now obviously make. Then make install. Once install is ready, we'll come out of this and we'll delete the extracted package. Clear? Now the next part is, which is pass 3, which is Binutils. Now pass 3 of Binutils pass 3. Okay. So before that, let me make sure expect is working properly or not. Yes, it is. Let me prepare a Binutils build directory. Let me prepare that. I did, and let me extract the Binutils package. Now extraction is done. Let's go inside the Binutils build, same old story, and from here we'll be installing our Binutils. So configure, and there will be only one change, that is prefix is equal to usr. As you can see, prefix is equal to usr. Clear? Once that is done, let's make hit the make, that too inside /usr. Once make is done, we'll be installing Binutils packages inside /usr. That is what we'll be doing now. And the next one is make install inside /usr. That is done. So let's come out of this directory and delete the Binutils build as well as extracted Binutils package directory. So we're done with the Binutils pass 3. Now the remaining package is only GCC. GCC's pass 3 we have to do. So obviously there will be GMP, MP, MPC, and all dependencies also we need to resolve. Same story what we followed in pass1 and pass2. So let's go inside GMP and configure it. Let me quickly do it. Prefix will be USR. Then make. After that, before we install, we'll be doing a make HTML as well to prepare the HTML files as well. Those are the most probably those will be documentation files. Next is make HTML. Once HTML is done, it's time for make install. After make install, we need to install the HTML files as well at the correct location. So we are done with the GMP. Now come out of this and delete the extracted GMP package. As you know, GMP is a dependency of a GCC. Next is MPFR. Extracted the MPFR. Let's go inside a MPFR extracted package, and there is one patch. Let's patch it. It patched. Next is obviously configure with prefix as USR. Then make HTML, then make install, and make install HTML. We were done with the MPFR. So we're done with the configure. Next is make. So we're done with the make. Now make HTML to prepare the HTML file. Now make obviously install. Once we're done with the make install, let's install the HTML packages. Come out of this directory and delete the MPFR extracted package. Done. Now obviously it's time for the MPSC. So these are the dependencies. These three are the dependencies of GCC. So once we resolve these dependencies, we will go for the GCC pass3, and the only change will be prefix is equal to /USR. Now this is done. Make, as you know, then obviously make HTML after this. Make HTML, then make install HTML. That's it. Now let's come out of this directory and delete the extracted MPC package temporary directory. Now this is a time of our pass3 of GCC. It will take some time. Now create the temporary directory. Let's go inside that GCC build temporary directory and obviously the configure. It should be prefix USR. Configure is done. Let's go for the make. Now this make will take a long time. On this system, it will take around 13 minutes. We're done with the make. Next, what we need to do, we need to increase the stack size. Even if you don't do it, it will be okay. Just sake of increasing it, you increase the stack size, and obviously the make install. Now this make install will again take 6 minutes. Can't help. Done with the make install. Now we need to do some changes like creating a symlink and all. We need to do some changes. So let me simply copy it and paste. So our CPP symlink we have created, then CC and GCC both are same. That symlink we need to create. Then we need to create one directory. Let me create that with the help of install. Then again we need to make one symlink. Let me make that symlink. We need to create some directories inside /usr. Let me create those directories. Then move the files and some of the files at the correct location. And we are done. So let me come out of this and delete the temporary directory as well as the extracted package. So installing every package manually is a difficult task. So I will be starting a script now. So as of up to this stage, we are done with our pass3. We made our toolchain, we adjusted the toolchain. Now by using this pass3, we will be compiling our remaining packages. So let's do it. And the script which I will be running is core1.sh. Last time we ran core0.sh. This time we are running core1.sh. Let me hit the enter. And the script has been started. As you can see, the package which we are installing is bzip2. And for the configure is prefix. Prefix will be /usr. After that, next package is Pkg-config. That is the package we are installing. Pkg-config is responsible for tools like library paths, build tools, doing the configure and makefile execution. So Pkg-config package contains a tool for passing the include path for libraries, for build tools, and for makefile execution. That is what the job of Pkg-config. So it's getting compiled. After Pkg-config, next package is Ncurses. We already talked about Ncurses. So basically we are reinstalling it. Earlier we installed inside the tools. Now we are reinstalling it inside /usr. As you can see, the prefix is /usr. You can see the output here. And the error messages are here. Next, the make command is fired through the script of Ncurses. Make install. Next package is attributes, which provides the extended attributes. After attributes, the next package was ACL. We also know that access control list, and after access control list, it's the libcap. After the libcap, we are installing currently the sed package. We know the sed. After sed, we'll be going for the next package, that will be shadow. Here we go with the shadow package. So installing the next package as a shadow. Compilation has been started. So this is the same shadow package which provides to the /etc shadow like files and all, where it stores the password and all. Next is after shadow, the next package is Psmisc. That package is responsible for providing you some binaries like fuser, killall, ps3, pkfd. These like binaries it provides. After that, it's Procps is the package. Procps is obviously for the free command, top command, slaptop, ps, pkill, sysctl, uptime, vmstat, wwatch. These like commands it provides. And that was the last package which we installed through this script. Now why we stopped here? Because we need to set the password of root user of our LFS. So whenever we will build our LFS, when we reboot and we'll boot with our LFS, it will ask for a root username and password. Root user we have added, and then we install the shadow package. So obviously the password has to be set, so that it will go inside a shadow package. So let's set the password, which is root. I said the very simple package. Next package is E2FS proc. So let me extract the package, that is E2FS procs. I have extracted it. Next, let me go inside that package, cd e2 fs procs. I went inside. I need to create one temporary directory for it. Let me create a temporary directory. This time I will use name only build. Let me go inside that temporary directory. And we need to hit the configure. So let me copy the configure command from the LFS book. The configure has been started. Prefix will be /usr. Then the next command is make. Make has been started. After make, we need to create two symlinks. After creating the symlink, we'll be going next for make install. Let's create the symlink. We created the symlink, and let's do a make install. Next is some libraries we need to install with the help of make install libs. Change the permission. We need to provide the right permissions to some of the files. So we just provided those permissions. Then we need to use the gun zip and create one .info file after that. So let me create. Now these are those particular package specific commands. cd .rm-rf build was the temporary directory, and e2 fs procs is the, and e2 fsck is responsible for dum2fs. It provides dum2fs, e2 fsck, e2 label, fsck, mkfs, resize2fs. So related to file system related programs it provides. Clear? Now let's run the another script which is core2.sh this time. Let me hit the enter. The compilation has been started. As you can see, we are reinstalling the Coreutils. We already seen that Coreutils is one of the important packages. It provides cat, chown, date, dd, cut, df, du, echo, chgroup, chmod, cp, head, ln, ls, mkdir, mknode, mv, nice, nproc, paste, printf, rm, rmdr, sleep, sort, wc, who. These all packages are provided by the Coreutils. So one of the most important package is Coreutils. So we are configuring it and we are installing it inside a /usr. Earlier also we installed the Coreutils, but that we install inside /tools. Now make. As you can see, it is file make is running. It's compiling through our CC, that is GCC. So make is done. Now it's going for make install. Next package is Iana-Etc. It is responsible for providing etc protocols and etc services. Next is M4. That's a microprocessor. We know that. We are reinstalling. Earlier also we installed. Now also we are reinstalling inside /usr. After M4, we need to install the Flex. This Flex package contains the utility for generating programs that recognize patterns in text. For that, Flex is necessary. So that is what we are installing now, Flex. After Flex, we'll be installing the package named as Bison. So then Bison package contains a parser generator that will be installing. So we're done with the Flex. Now we are installing Bison. As you can see, next package is Grep. After Bison, we will be installing the package Grep. We all know the Grep binary. So as you can see, we are installing a Grep package. We all know the Grep binary. We are installing it inside USR. Clear? Now after make, we are installing Readline package. That package is responsible for providing some libraries which will be helpful for command line editing and the history. So we are installing the Readline. After Readline, we are installing the bash, our bash. We'll be installing it inside /usr. The moment we install the bash, our script will stop running and as you can, the script has been stopped because this command has been executed. Execute the bin bash. So obviously it provided a new bash. So this is it for this video. In next video, we will install remaining packages. I hope you are enjoying this video series. If you have not subscribed yet, please subscribe, share and like. This is Yogesh Babar signing off.